Good morning, class. Welcome to this session of Modern Organization and Management. I hope I am audible to you. Okay. So, now in our last session, we were discussing regarding decision making conditions. Now, this was the particular topic that we were discussing in our earlier session. So, we spoke regarding how under decision making we can in a continuum decide the condition to be a condition where there is totality of certainty, and a midway through the two ends, that is a condition where some of the facts we shall be knowing and the some facts we'll have to percept, that we call as condition of risk. And at the end of the continuum where we have no certainty at all, or the information what we have is in total ambiguity, is called as condition of complete uncertainty. Now we had seen example for each of it, and we had spoken regarding the entire decision making condition in detail. Now if I have to just you know wind it up in few sentences. Now when we tell regarding certainty, it is simply that when the decision makers, he knows with reasonable certainty what are the different alternatives that he has and what conditions are associated with each alternative. Now we can tell that a state of certainty exists, by giving an example. Now for that, take into consideration that, for example, you know a company. A company considers rupees 1 lakh investment in new equipment, and that the company knows for certain that at the end it is going to get a yield of 40,000 in cost savings per year, maybe over the next 5 years. Now managers, from this information, they can calculate all the before tax rate of return of about 40%. Now if the manager is able to compare this investment opportunity with one that might yield only rupees 30,000 per year in cost saving, then they have this option of choosing safely the 40% alternative for return. Now, but we should also remember that few decisions are certain in real world and most contain risk of uncertainty. So the next one we have is risk. Now risk means that a decision has clear cut goals and that good information, that is information would be incomplete, but information would be reliable and factual. Such information is available, but then the future outcomes which are associated with each of the alternative shall always be subjective to chance. Therefore in such case, what happens is some information is available, but it shall be insufficient to answer all the questions that you will have to answer regarding the outcome of the situation. Now we can take example of McDonald's. Now, what happened with this company was it took a calculated risk and lost with the introduction of its what is called as Arc Deluxe sandwich line. Now, McDonald's, it had information that showed that a line of sandwiches which is targeted towards adults would be successful. But the Arc Deluxe sandwich was introduced at a cost of $100 million, but then it flopped in the marketplace because reliable information, though incomplete, is still useful to managers in coping with risk, since they can employ it to calculate the probability that a given event will take place and then pick up a decision alternative with favorable odds. Now, the next one is regarding the uncertainty. As we discussed earlier, under conditions of uncertainty, the decision maker does not know all alternatives that are available, and the risk associated with each or the likely consequence of each alternative. So, this uncertainty basically comes from the complex and dynamic nature of today's organizations and the environment in which they'll have to work, and the decisions are generally made on the basis of most of the decisions on guesses than on factual data. Having said this, there can be another situation also which can be termed as ambiguity. Now, ambiguity means that the goals, which are to be achieved or the problem to be solved shall be unclear. Now, alternatives are always difficult to define, and information about outcomes is not available. Now, it is like, a teacher asking his students to complete an assignment, maybe without giving any kind of guidelines. Now, ambiguity, naturally is most difficult decision situation which the manager has to face. And this shall definitely exist in the rapidly changing environment. But then, despite all such difficulties, despite all such odds, managers are always expected to catch up with the goals, develop the most well scenarios for decision alternatives, and thereby somehow come up with acceptable solution. Fortunately, most decisions do not fall under this category of ambiguity. If I have to tell about ambiguity once again, here the goal to be achieved or the problem to be solved shall be unclear, alternatives are difficult to spell out, and information about outcomes shall also be not available. Now, this was the example for decision making condition under certainty. This particular slide we explained regarding decision making condition under risk. Then with this particular slide we spoke regarding decision making conditions under uncertainty, that is when it is maximax, when it is maximin, when it is minimax, and insufficient reason. Then with this particular slide, we give example for all the four different criteria. Okay. Now we shall see in detail some of the technique of or the quantitative techniques for decision making, or wherein yes, before I continue, I'd like to tell, please do not try to admit yourself to the class in between when it is going on. If you do so, I'll have to come back and admit you to the meeting. Since I've taken your email ID, I've given you access, please try to join from the same ID which you have given to me. Otherwise, it will be a waste of time for me and for you as well. So please take into consideration that the email ID which you had given for the class, please try to join from that, or please do give me your new email ID so that I need not waste time behind admitting you to the class. So please consider this. Yes. Now speaking about quantitative techniques for decision making, there are a lot of different techniques which you can use. Or in simple, all these decisions are made such that you have data, you have those data which can be converted into numbers, and based on what results we get, we tend to take decision. And on all such situation where we take decision based on such techniques are called as quantitative techniques. Now if you go through your syllabus. Now in your syllabus there is something called as quantitative approach. Uh, the heading is different, I guess, different approaches of decision making, and in that first one it is quantitative approach. So all this that has been listed being presented to you in this particular slide are the topics which can be considered under quantitative approach. Now, one more thing about this is that each of the quantitative, the approach that has been given can be studied as a separate subject. So, in brief, I would be telling you all, if you are interested, you are always welcome to go and study back each of the technique in detail. Okay. Now, let us speak about the first one and the most often used and the most popular one, that is operation research, or OR. You might have probably heard about this. The operation research is nothing but it is the application of different scientific methods so that we can study the different alternatives when we are encountered with the problem situation. And this particular work of studying scientifically the different alternatives that are available, we do it with the main aim or with the view to obtain quantitative basis decision, or in other words, for arriving at a best solution. Here what we can observe is that the importance and the emphasis shall always be on the scientific method, that is on the use of quantitative data, on goals, and on the determination of the best means of reaching the goal. Now operation research is one of the quantitative data, and under operation research we have decision tree. Under operation research we have probability theory, we have linear programming, we have game theory, we have queuing theory, and also we have management information system. Now all this comes under your operation research or quantitative techniques for decision making. So we shall see operation research in detail. So when we tell operation research, it simply means different things to different people. Now for some of the researchers or for some of the academicians, when they mention operation research, it includes all quantitative decision techniques. Okay. We can take the example of one of the definition which has been given by American Encyclopedia of Management. It tells operation research is the quantitative study of an organization in action carried out in order to find ways in which its functions can be improved is called OR. Now operation research, when it is abbreviated, it is called as OR. Now this was the definition which was given by American Encyclopedia of Management. Okay, now what I would like to suggest is listen to all these things, try to understand it. Regarding the study material, I shall definitely circulate, so you need not worry regarding that. So listen, try understanding. If you have any doubts, you do ask. Other than that, don't go behind the work of writing it down. Okay, whatever I tell, if you can take down at once when I tell, take it down. I shall be unable to repeat it because there are a lot of things that has to be said. So if you are able to take down, take down. Otherwise, go check some textbooks, or I shall definitely send you all the study material. Now this is the to the point this definition has been given, where they are telling that it's a quantitative study of an organization uh, which has been done with the main aim of finding ways in which the functions of the organizations can be improved. Now some of the academicians, they take operation research in a broad sense. uh, Accordingly, there are two of them research called as Miller and Starr. They described organization research as applied decisions theory, where the managers, they try to achieve a rationality when they are dealing with problems, and to this they do it through the use of scientific, logical, or mathematical means. So the definition of OR, if you see, it suggests that various elements of problem on which decision is to be made are expressed in numerical forms. Now the relationship among these elements are established and the decision is made on the basis of analysis of the relationship. So, from this we can make out some of the characteristics of operation research. The first one is that definitely operation research gives importance for models, that is the logical and physical presentation of a reality or problem. So, the model is could be a representation of objects, it could be a representation of a process, it could be a representation of system or even events. Now the model may be simple or complex depending on the type of variables that are being involved in it. That is to tell, the entire problem shall be presented in the form of model which can be easily understood by others. Next one is it quantifies variables. Now it shall quantify variable or the problem it shall convert into numbers to the most extent possible, because only quantifiable data can be inserted into a method so that measurable results can be calculated. The third characteristic is that it gives importance for goals. Now, goals, especially in a problem area, and it sees to that the development of measures of effectiveness in understanding whether a given solution shows a promise of achieving these goals, or whether these solutions could never reach to the goals. Now, every solution that has been proposed regarding the problem will be arranged according to the variables so that the end results, they can be compared against the measures that has been created. Now, it also incorporates important decisions. That is to tell, operation research, it tries to implement in the model all the different variables of a particular problem, and thereby it will tell that one solution which appears to be the most important in finding the solution for a problem. So these are some of the characteristics. The list is not exhaustive. If you have your own idea or if you have knowledge regarding the particular subject, you can always add, include, rearrange, or might even make the particular answer better. The next one, we shall see some of the role of operation research, or nothing but how does this operation research helps in decision making when it comes for an organization, any kind of organization. Now, as we discussed earlier, this particular operation research, it has been developed mainly with the aim of solving the problems of complex decision making. Now, the complexity, if we observe the history of business or world business, the complexity of business decision, it increased especially after the Second World War, because after that there was a huge increase in the size of organization and increasing complexity of the business environment. Now what happened during the world war is that the basic problem before most of the country was to optimize defense activities so that they can get the best results. Now, if we observe the dynamic and complex society or so, this business environment, Business managers face almost the similar problem of using limited resources so as to achieve the organizational objectives. Now, when we spoke regarding military and operation research, the relation or the link is that operation research as a field of study was developed during World War. Now, what happened was each country had limited resources that they could use in the war. So, they had to come up with ways in which they could use minimum resources as possible and thereby come up with a better result. From there, the operational research started to develop. And in today's world, today's business environment, what happens is that no matter how big a business organization is, it is always has this problem of limited resources in one way or the other. So even the same situation exists here, wherein the manager has to decide how well can he use his limited resources and get the most out of it. Now speaking regarding the scope of uh, operational research, it now scope tells that what are the areas does a particular topic or particular field of knowledge has for or has under its purview or its meaning. Now, operational research, it covers almost the entire business activities. And therefore, operation research can be used in business structure, long range planning, production, materials handling and layouts, maybe materials control, research and development, personnel is employees, so employees problems, distribution of products, selling and marketing, financial problems, and in all other different wing of the business organization. So, from the example that we just discussed, we can probably see that operation research covers almost the entire range of business activities in a business organization. So, for every other field where the variables of the problems can be quantified, we can definitely use operation research in all those to get optimized result and better results. And the second one is definitely operation research. It helps in optimum allocation of resources in the organization. Now, this goes without telling that the main problem before any organization is the question regarding how to allocate limited resources to various units and subunits in the organization, and so that every resource is utilized in the best way. Because of the large size of the organization, definitely it needs division of labor, creating large number of interdependent units and subunits. Now all work together to achieve objectives. But then these units always have the tendency to grow autonomously with each one of them. Now each one of them shall be in competition with one another for higher resource allocation. And this shall always create a problem before the head of the managers or the head of the organization as to how to distribute the limited resource among the various departments in the organization. And in such case, operational research will always give techniques for effectively deciding how to allocate the limited resource in the organization. And the third one is it helps in quick decision making. Now, what I mean to tell is that in business world, the competition is ever growing. It can be in terms of national and international markets also. And this particular situation has, it has made it that quick decisions are to be taken by the managers so that they can take the advantage of market factors. Now, the decision should be quick as well as sound. That is to tell, no matter how quick you have to take the decisions with half information or with half perception, you are expected always you take a decision which is advantageous for the organization. One mistake can result in huge problems. So this requires the analysis of hundreds of variables simultaneously, and this can be done using scientific analysis. Now this is exactly what OR does. It combines different disciplines, that is mathematics, statistics, economics, engineering, and that with a combined effort of all this knowledge, the problem can be looked into greater detail with more precious answer of the problem. And while using OR techniques, manager has to quantify different variables which require greater precision in defining a variable involved in decision making. Now, um, from the role of operation, what we discussed is that how it is benefited for an organization, how advantageous can operation research can be for an organization. Having said this, the question might arise, so if it is so good for organization, is there any chance that it has some kind of defects? And definitely there are some of the limitations in using operation research. Now, definitely operation research, it contributes in different ways in making very good decisions, especially when, several variables are to be considered in decision. But then it should not be treated as the final word in decision making. But then it is, always suggested to treat operation research just like an help in decision making. And also there are certain limitations which can make this operation research somewhat limited in most of the cases, though many of the limitations are related with the time and cost. Managers should be well aware of these limitations which are you know maybe a threat for the organization sometime. And the first one is magnitude of calculation. From this we can understand it is nothing but there shall be a lot of calculation, there shall be huge variables considered. And also we should know for a fact that the result shall be based on what data we feed. So if the data itself is not genuine, then definitely it is going to create a lot of problem in the organization. Now, this operation research, it always tries to, optimize the solution for a problem by taking account of all the variables relating to the problem. Now, in modern society or modern business world, these variables are definitely numerous, and expressing them in quantity and building relationship among these requires huge calculation. Now all this calculation requires undoubtedly the use of computer, which will involve cost on the part of organization. Therefore, managers should evaluate the cost of optimizing the solution in light of the benefit occurring from it. That is to tell, yes, there might be bigger organization which can implement the OR without much of difficulties. But is the process same for small organization? Because for small organization, the cost involved in implementing operation research might be prohibitive. Therefore, the use of operation techniques is limited only to those organizations which can afford this cost. The next one is lack of quantification of variables. What does this mean? Now, a basic limitation in operation research is that it provides solution only when all the variables related to problem can be quantified. But then we should also never forget the fact that a business decision is also affected by numerous variables, and some of them may not be quantified. Especially the intangible factors like human relations, managerial perceptions can never be quantified, and therefore operation research cannot make use of these factors, though these may be equally or sometimes even more important variables affecting the situation of a problem. Thus, optimization of solutions cannot be arrived at if these factors are not considered adequately. And the last one is gap between manager and operations research analyst. So what does this mean? Now, when we implement operation research in organization, sometimes what happens is that a particular practical problem comes in the way of using this operation research, because there shall exist a gap between the manager and the OR analyst. Now, that is to tell a manager may not be, you know, very well having the knowledge with the OR techniques. Similarly, an operational research analyst may not be aware of a business problem. And this is where there exists a gap between those who have the solution and those who have who provide the solution. Now, this is the reason why many business managers do not appreciate the role of operational research in solving the business problems. However, this is basically the problem of training. Training is required for both. For managers, it is required so that they can appreciate the role of operation research and the types of problems that can be solved, and to the operational research analysis, so that the person can learn how to identify and quantify the variables affecting the business problems. Once the working knowledge is acquired by them, there may not be such problem. But then, in spite of the above limitation, or operation research techniques are getting popularity in solving business problems, Even the small organizations are going for quantitative way of decision making with the passage of time. Now this is likely to happen with much faster pace. There are various techniques and tools of operation research. But then for business decision, some of the techniques that can be commonly used are, as we discussed, decision tree, linear programming, game theory, queuing theory. So each one of this we shall see in detail. But then before that, before starting decision tree, uh, maybe you can take a break of a minute. Then we can start it once again. Take a break of 30 seconds or a minute. Then we shall start with decision tree. So we shall discuss the one of the form of operation research, that is decision tree. So what basically is a decision tree? The name sounds is interesting, isn't it? So what this probably could be. Now, when we take business decisions, there shall be some of the decisions which involves different series of steps. Now, the second step shall always depend on the outcome of the first, and the third depending on the outcome of the second, and it goes so on, as you can see in the diagram. Now, often uncertainty shall be surrounding each of the step. So the decision maker always face uncertainty one above the other uncertainty. Now, decision tree are such a model for solving problems where there are a lot of uncertainty. Now, it is one of the graphical method for identifying alternative actions, estimating probabilities, and indicating the result expected. And this graphical form, it visually helps the decision maker view his alternatives and also the outcomes of the result. Now, instead of compressing all the information regarding a complex decision into a table, what a decision maker does is that he can draw a schematic representation of the problem that displays the information in more easily and also more understandable way. Now, if I have to give an example regarding the problems which can be solved through decision tree, maybe in an organization when a new product has to be introduced. Now, whether to go up for it in a major way so as to assure production at the lowest possible cost, or to undertake cheaper temporary tooling involving a higher manufacturing cost but lower capital losses, Or if the product does not sell as well as estimated, what has to be done? These are some of the questions which can be taken under decision tree. And when we take all such problems under decision tree, the second step of the decision, that is going for major or minor tooling, depends upon the outcome of the first decision, that is whether to go for new product or not. Similarly, when we take decision regarding tooling, there may be alternatives which can be considered in the light of decision made on tooling. So, how do we draw this tree of decision or the construction of decision tree? The entire process can be put in three different steps. Now, the construction of decision tree requires firstly definition of alternatives, secondly estimation of probabilities for various elements, and lastly calculation of expected payoffs resulting from an action. Now, as we are discussing the first step, the first basic step in the construction of decision tree is definition of various alternatives which are available in hand. That is nothing but, if I have to give an example, is to tell if an organization want to introduce a new product in the market, we can consider that it has two alternatives which are available to it. First one is it can go for creating permanent tooling, or the second one that it can go for temporary tooling. Now each of the alternative will require different investment. However, since the chance for success or failure of the new product cannot be predicted with certainty, the decision cannot be made purely on the basis of investment criteria. Now the organization has some idea whether to go with it, not to go with it. Now the second step in decision tree requires the estimation of probabilities. Now it will be based on manager's own experience and maybe from consultation with other experts and also from the information available in respect with these questions. Now, taken that there might be three alternatives regarding the success or failure of the product is concerned. Now, it may have high success, it may have moderate success, or then there is the other chance that the product might fail. And the probability of each event will also be different. And the third step is the calculation of the payoffs from each alternative in various events. Now, had there been certainty of events, the payoff table would be as shown in your PPT. Okay, but then given probabilities, the payoff table can be prepared as shown in the decision tree. Now the decision tree is the figure that is there below or in the bottom right hand side corner, and the table is in the upper right hand side corner. Now the same steps can be repeated for further alternatives and events. Now regarding whatever I said regarding coming up with the decision of whether to introduce a new product or not. See, based on the initial investment, they have two alternatives. Either to go for permanent tooling, which will be having investment of 2 crores, required, or temporary tooling which requires rupees 1 crore. Now, what is the payoff if they consider this? Now, the alternatives they have two, and there are chances that the product might succeed. The product might succeed moderately, or there is chances that the product might fail. Under permanent tooling, uh, the payoff is rupees 1 crore if product succeeds. If the product succeeds moderately, then the payoff would be half crore, and if the product fails, the company is going to lose 2 crores, the entire amount that it has invested. Under temporary tooling, if the product succeeds, the payoff would be 60 crore. If it succeeds moderately, then the company is going to get a payoff of 30 crore, sorry, 30% of 1 crore or 30 lakhs. And if the product fails, the entire investment of 1 crore shall be lost. Now, these expected returns may be available for a number of years. And they have also given the probability of events. That is to tell, there is 50% probability that product succeeds. There is 30% chances that product might have a moderate success, and there is 20% chance that product may fail. So this is shown in terms of table. Now, this can also be drawn in the form of decision tree. Now, each of the square shape speaks regarding the decision point, and each circle speaks about choice event. Now, in investing, it has two alternatives: permanent tooling or temporary tooling. Permanent tooling, the product shall succeed 50%. It is going to have a payoff of 0.50 crores. Moderate success, 0.3, that is, it can have a payoff of 0.15 crore, or failure, there is chance of 0.1% and rupees 20 lakh crores for loss. The same under the same under temporary tooling also they have mentioned regarding the probabilities 0.5, 0.3 and 0.1 and the cost that is being involved. And they have termed each of the decisions in respect of computation and when there is no computation for the product. With failure, that decision cannot be made because a failure product definitely will not have any of the computation. Now, if we see this decision tree, the payoff for an ultimate alternative has been calculated by taking into the probabilities of the alternative as well as the previous alternatives and multiplied by the expected payoff of the first alternative without its probability. I'll repeat it once again. The payoff for an ultimate alternative has been calculated by taking into account the probability of the ultimate alternative as well as the previous alternative and multiplied by the expected payoff first alternative without its probability. If we are telling it in terms of this particular decision tree, now the expected payoff permanent tooling, if product succeeds and computation exists, would be 1.0 into 0.5 into 0.8. Or in other words, it can also be 0.5 into 0.8. Or if you have to tell it in numbers, it shall be 40 lakhs. Now, in the same way, payouts for other alternatives shall also be calculated. Now, the total pay of each alternative will be the basis for decision. Now, in the same case, the total pay for permanent tooling, be with me when I tell this, for permanent tooling is rupees 45 lakh per annum, while that for temporary tooling shall be 29 lakh per annum. Therefore, in terms of total payoff, it is better to select permanent tooling. However, if the return on investment is taken into consideration, temporary tooling might be selected. Therefore, besides payoff as given in decision tree, other factors like availability of funds, risk taking capacity and preference will also decide the selection of alternatives. Now, this was the first example, but remember, when decisions are based on decision tree, it always becomes more complicated as chance event increases. Now, the compounding of probabilities makes the solution much more difficult. Therefore, it always needs the help or assistance of a computer. And also, there may be decision points in a single decision, over a period of time. That is to tell, um, from the example that we taken, the manager may go for temporary tooling at the initial stage, but may think of permanent tooling at a later stage. Or there are chances that he might incorporate a new feature in the product which might result into change in the probability of its success, or may substitute the product and so on. So such decisions can be chalked out on the basis of decision tree. So now, if at all this particular example was difficult or complex for you, we can take into consider another example. Now, see, one thing you will have to remember is that all these are hypothetical situations which does not happen actually in the business world, because in business world the variables for a decision or a problem won't be limited for 2 or 3 as we have in this particular example. There will be a lot of variables and the problems also will be too much in number. Now just take into the consideration, uh, you know, consider an investor who has prepared to shell down, or invest rupees 1 lakh in the form of investment for one particular year. Now the investor starts by isolating three opportunities and their respective financial returns. He has three alternatives of A, B, C, and the outcome under each would be 20,000, 30,000 and 50,000. Okay, and the probabilities would be 0.5, 0.5, 0.3, 0.2, and the expected values for ABC would be 17,000, 18,500 and 15,000. Now the following information has been provided. Now, what we can observe from this table is that if the investor is investing in alternative A, his chances of getting a return of 10,000 are 0.5% or 50%, whereas the chance is 30% for getting double return. And 20% for getting the triple return. Similarly, the expected returns and the expected probabilities for the rest of the alternative investment opportunities has been mentioned in the table. Now the investor then he will calculate based on some arithmetic solutions or arithmetic data the expected value of the returns from a probability with each of the outcome. Now in this particular case that we have taken, in order to get the expected value from the investment in A, we'll have to use the simple mathematics where we can put, if it is 10,000, there are chances that 50% of the outcome is there. So 10,000 into that is so that is 10,000 into 0.5 plus 20,000. If we have to get double return, there are chances that it happens on 0.3 basis. And if we have to get triple return, that is 30,000, then there are probability that it happens for a 20% basis. So the expected value would be 17,000. Now the same problem can be analyzed through a decision tree. Now the same happens with the decision tree. Now the decision would be, maybe second one we'll take. The decision would be to invest in alternative B, since it yields highest return of, as we can see in the table, 18,500 when compared to other investment alternative. Now decision 3 through such means will provide a comparatively simple graphic method for analyzing the potential outcomes of complex problem and arriving at a satisfactory solution. Now it offers the decision maker a way of showing the future courses mathematically. Now decision tree provides an advantage of clearly telling what really goes on in decision making process. It also is helpful in the hands of manager who have to make systematic decision. Now in this diagram you can see that there are three alternatives of 17,000, 18,500 and 15,000. How did they reach? That is, when you have 0.5 probability for 10,000, it shall be 5,000 because the initial investment that they have made is 10,000, and for points 3 for rupees 20,000 there shall be 6,000, that is point 0.3 into 20,000. For 22% for point 2 probability for 30,000 it shall be 6,000 for the tripling of the investment. So the first alternative would give 17,000 as the payoff. For the second one it shall be 0.5 into 15,000 where you will have 7,500. 0.3 probability for rupees 30,000, it would be 9,000, and zero point 0.2 for 10,000, it shall be 2,000. And for alternative C, it is 0.5 for 5,000, 0.3 for 15,000, and 0.2 for 40,000. See here, this outcome is for all the three outcomes in rupees. For A it is 10,000, 20,000 and 30 for the probability of 5, 3 and 2. I hope this decision tree is clear. It is nothing but instead of mentioning in the form of table, they are just trying to mention it in the form of decision tree. That's it they are doing. The answer that you get in the table or in the tree is the same. Now speaking about the uses of decision tree, along the way we have discussed, but then even then what we can see is that first thing, it helps to make decision in complex situation, particularly when outcome of the later situation is depending on the outcome of the former step. Now what is significant about the decision tree approach is that it does several things for decision making. Especially it makes possible for the decision maker to see, at least the major alternatives open to them, and the subsequent decisions maybe depend on the events of the future. And speaking about more usefulness, um, by incorporating probabilities of various different events in the decision tree, it is also possible to come up with actual probability of a decision leading to desired results. So there are also some of the limitations. The main thing is that the complexity that is involved. Even for this simple example that we took with just two variables, there was a lot of confusion with regard to that. Only those who are well versed with it can do it. Now, it is to tell, even though it is, you know, um, even though the decision tree is simple in doing, it is complex in application. And also, it becomes so complex that relationship among various events and alternatives cannot be established at all. And there are chances that there can be too many alternatives also sometimes. And even with simple two or three branch fruits, the tree can be quite complex. So these are some of the problems. Okay. The next one under the operation research is probability theory. Now this probability theory is something we have already discussed. or when we spoke regarding probability. It is very easy to understand. Now, uh, if we observe the business environment or the dynamics of the business uh, situation, one thing we can observe is that the results or the courses of future events can never be predicted with 100% certainty. And the most what we can do is we can reach approximate solution, you know, mainly on the basis of likelihood of some possible future event. Now we can assign certain value to the probability of occurrence of certain event. So when we speak about this probability, uh, it is not the fact that you do not know, but you might not have observed. The probability usually ranges from 0 to 1. That is, 1 is nothing but 100% of probability, and anything within it, that is 0.5%, 0.3, 0.8%. Now it represents the complete certainty. I mean, the 100% represents the complete certainty that an event will occur, and the 0 will be for non-occurrence of any event. So this probability theory, it provides a decision maker with a strong base for ascertaining the happening of future events. Now the probability can be subjective or objective. Now what is subjective, what is objective, we have already discussed. Subjective is where it can be based on perception, past experience. Objective is it is based purely on the results. But a manager quite frequently is concerned with objective probability, because subjective probabilities are educated guesses, whereas objective probabilities are based on data. Now, out of these two approaches, objective probability is preferred to the subjective probability. But sometimes objective probability may have to be, tweaked, tempered based upon the judgment, based upon the experience, and also based upon the intuition of the one who has to decide. Because one thing remember, even though we are making an objective decision, it is based on our data. The characteristic of the data shall always be the fact that it is a historical data, and the past can never be a complete predicator of future. Therefore, the ascendant circumstances, they'll have to be analyzed by the manager when he has to take decision. Now, application of probability theory to, various different areas, uh, like maybe quantitative methods, or especially when we speak of decision making, is becoming more and more important in today's business world. Now, this probability theory, we apply it in pricing, we apply it in product innovation, also in marketing research, and also all such other related areas. Now, probability theory, has made substantial inroads in decision making. You might have heard things like binomial, exponential, Poisson, normal, and beta distributions. All these are nothing but probability theories, and which are being used in business so as to reach the result. Okay. The next one is that we shall see regarding linear programming. What is this linear programming? Now, you might have observed this or this particular thing uh, in your mathematics syllabus. That is where we draw a graph, where we have equation, and on the basis of equation and some known variable, some unknown variable, we reach out for a solution. That is basically linear programming or LP. Now, it is the technique which we use for making the resources optimum in nature in the business organization. No, that is to tell when we speak of this, um, optimum utilization, it is nothing but what happens in business organization is each resources is available in its own specific quantity, and at any point of time the availability is the maximum setting a limit or restriction. Now, the problem that the management faces is to decide a way in which these limited resources can be put to different use. But then it should always be seen that not only different use, there should be maximizing the achievement of organizational objective. So, this linear programming is a mathematical technique basically for the purpose of allocation of limited resources in optimum manner. When we tell linear or the word linear, it stands for the relationship handled are those which are represented by straight lines, something like this. Now, the word programming means making decisions systematically. In other words, it is a decision making technique under given constraints based on the assumption that the relationship among the variables representing different phenomena shows linearity. Therefore, LP is the maximization of linear functions of variables subject to a constraint of linear inequality. Now, once again I shall repeat, this has been given in your syllabus as quantitative approach. You'll have to know what quantitative approaches is. Now, I'm sure in detail each one of it will definitely be not asked. They'll never ask you a question, what is gaming theory, or they'll never ask you a question, what is linear programming, or what is a decision tree. They'll just ask you, maybe there are chances they might ask, please mention how quantitative techniques would help in decision making. During such times, you should be able to explain what it is. So, what I suggest is each of the theory, know how it works, what it does in simple words. Maybe decision tree, it is just that what can be shown in table can be shown in the form of tree, so that it is helpful for decision making. That is all regarding decision tree. And operation research is entirely that thing where quantitative data are used for decision making. So, LPP uses lines, graphs, some known variable, some unknown variable, or what we call in terms of mathematics the linear functions or the constraints and linear inequalities. So, I basically would be telling it in the way it is. So, you can write it on the basis of, in a simple way, how a manager is able to understand it. Now, let us see the features of linear programming. The first one is objective function. So just now we were discussing some under probability, how there are some decisions are based on objective, how some are subjective. Now LP undoubtedly is objective based function. Now, the objective sought to be achieved by the application of LP in solving the problem is known as objective function. That is to tell, in the problem there must be clearly defined objectives and should be expressed quantitatively. Now when it comes to business problems, this can be expressed as maximization of profit or minimization of cost or any such thing which can be probably mentioned in terms of numbers. The next one is constraints. Now what are these? Now these are the restrictions which shall be put on decision variables. Now they may be in terms of availability of raw materials when it comes to an organization. They may be in terms of the machine time that has to be used. It can be in terms of labor or any such thing. Now the constraint must be capable of all the arithmetical expression. Then we have something called as non-negative condition. Now this LP model essentially seeks that the value for each variable can be either positive or it can be 0. In no case it can be negative. That's one thing we'll have to remember. If at all it becomes negative, the whole technique will be rendered useless. That is to tell, if an organization, considering allocation of resources for 3 different products, each product should be either positive or 0. That is not produced at all. Negative condition means that the product is dismantled, which is not at all a logical thing. And one more feature that can be spoken of is the linear relationship. That is to tell, the various relationships to be expressed either in the form of equation or inequality must be linear. Now the adjective that we use, the linear, is used to describe a proportional relationship between two or among more variables. That is to tell, additional inputs will produce the output in the same proportion in which the inputs are increased. That is to tell, the output of 2 machines and 2 workers should be double of 1 machine and 1 worker, and so on. These are some of the features of linear programming. We shall break here and we shall come back after 10 minutes. Now we were speaking about the linear programming. Now maybe then telling what it means and the features, if you see how it is constructed, probably you would get a better idea of what linear programming is all about. Now this linear programming, it can be solved by two ways, either from graphical method or what we call as simplex method. Now, when we speak of graphical method, it involves the use of the graphical methods that we normally use in economics, which usually has the close resemblance of indifferent curve analysis. This particular method is very simple but can be used conveniently, especially where two decision variables are to be considered. So, how can this linear programming can be you know used can be said very well with the help of example. So we will take into consideration a very hypothetical situation where we shall consider two products. The first one is product X and second one is product Y. Now regarding the selling price. Now the selling price of product X is each of the unit of product X costs rupees 20 and each of the unit of product Y costs rupees 25. Now the time that is required to produce product X is X requires 4 hours of machine A and 4 hours of machine B, whereas product Y requires 6 hours of machine A and 2 hours of machine B. So, the organization in total has 24 hours of machine A and 16 hours of machine B. That particular information has not been given here. Okay. Time available is machine A has machine A has 24 hours and machine B is available for 16 hours. Now the organization objective is simply revenue maximization, and also from the available alternatives, that is machine A and machine B, to come up with the optimum way of producing goods. So, how to formulate it using a LP method or linear programming method? So, this is the question, the information, and there we can see four different methods, or sorry, four different steps how we are able to reach to the point of answer. Now this is using graphical method. Then you have one more method, that is simplex method. Under graphical method there are four different steps how we can reach to the particular answer. Now the first step under linear programming is formulation of the problem or the definition of the problem. So, the first thing is nothing but whatever question you have or whatever problem you have, you will have to restate it in the mathematical form. Now, these are in the form of words. Now, you are expected to restate the entire problem in the way of mathematical problem. So, what is the main objective here? That we'll have to speak about the objective function or the main function. So, according to this question, what is the main function or main objective? Here, if we have to represent this particular problem in the way of mathematical formula, we should be able to speak about the relationship between the output and the revenue. Therefore, according to the objective, it is nothing but revenue maximization. Now, how do you think? How can this be maximized? Now, this particular revenue can be maximized when the highest number of product X is sold along with the highest number of Y is sold. So, if we have to represent it in the form of mathematical equation way, then it simply means 20x plus 25y. Why 20x and 25y? Because each unit of product X costs rupees 20 and each unit of product Y costs rupees 25. So when one, the revenue can be maximized when we add both the products, that is 20x and 25y. Now, this is the objective. But then, in the way of organization reaching its objective, there is some constraints or there are some limitations, and this has also been specifically mentioned in the question. Yes, the question, the limitation is that the problem states that to produce each unit of A and B, certain hours of machine A and B are necessary, but then the total amount of time the machines are available, there is a limitation. That is, machine A is available only for 24 hours and machine B is available only for 16 hours. So, the main basic constraint in this particular problem is the maximum time available on two machines, that is 24 hours for machine A and 16 hours for machine B. Now, this limited time available on two machines are to be distributed for producing the two products so that we can maximize the revenue. Now, the time requirement of each of the product is also different. That is, product X requires 4 hours of machine A and 4 hours of machine B, while product Y requires 6 hours of machine A and 2 hours of machine B. Therefore, various combination of two products can be produced within the constraint time availability on these two machines. Now, these constraints also should be expressed in the mathematical way. So, the equation shall be 4x plus 6y lesser than or equal to 24 and 4x plus 2y is lesser than equal to 16. Now, once after both the problem and the constraint is expressed mathematically, then comes the next step, where we'll have to plot the constraint on the graph. Now it should represent products. Now here in the problem we have taken product X on the X axis and product Y on the Y axis. Remember one thing, here the name of the product themselves has been given X and Y, but when you draw a graph, usually a line that is drawn towards the right hand side is always X axis, and the line that is drawn in the upward direction is always Y axis. Now the constraints, that is 4x plus 6y lesser than equal to b, can be plotted on the graph by first locating two terminal points and then joining these points by a straight line. That is, x-axis you have 4x plus 6y lesser than equal to 24. Now, if we assume that all the time available on machine A is utilized for producing X, 6 units can be produced. Thus, on the x-axis, the first point would be 6. That is nothing but 4 6 are 24. Similarly, in order to locate the second point, we can assume that the total time available on machine A is utilized to produce Y and 4 units are produced. Thus, the second point on Y axis is 4. Now, after locating these 2 points, these can be connected by drawing a straight line which is represented by C and D. Similarly, we can take for machine B, that is, if it will give 4 units of X axis and 8 units on Y axis. It is the straight line named E and F represents the use of machine B. Now the total graph would look something like it has been shown in your slide. Okay, once after everything is drawn, now you'll have to identify the feasibility region or the area what is good for organization. Now the feasibility area is found by, here when we speak graphically, it is found by the intersection of two lines, that is CD and EF. Now whatever area is covered by both the lines are nothing but feasibility region. Now the possible combination of production of two products X and Y within the given constraints of machine time available on A and B machine would be within the feasibility region of O, C, G, F. Now whatever comes within this is regarded as feasible. Now the optimum combination of two machine for products would lie on any corner of OCGF. Now in order to find out the most acceptable solution, each corner point must be tested in light of objectives. So it can be numerally represented as the one which has been shown in the table, that is O, C, F and G. You have product X, you have product Y. Under O, both shall be 0. For the corner point C, machine X shall be 0, whereas machine Y shall be 4. For corner point F, machine X shall be 4, whereas machine Y shall be 0. And for the corner point G, the machine X shall be 3, machine Y shall be 2. And the total revenue how we got is 0 into 20 plus 0 into 25. So both the products are 0, 0. For the next one, 0 into 20 plus 4 into 25 would be 100. For corner point F, 4 into 20 plus 0 into 25 shall be 80. And for corner point Z, 3 into 20 plus 2 into 25 would be 110. So since the basic objective in the problem is to maximize revenue, combination the corner point G will give out maximum output. So definitely it shall be selected. So this is how we reach out to the solution under the linear programming graphical method. Now in linear programming we have the second one, that is simplex method. I shall tell it in a very brief. Now the simplex method, it offers a way of solving much more complicated programming problems which involves large number of variables. In the way of graph, maybe two is can be done, but then when there are more number, definitely simplex method is suggested. Now two aspects of simplex method are to be remembered. The first one is the basic theory of the simplex method. It requires comparatively advanced mathematics involving a huge use of algebraic equations and the manipulation of all such equations. And the second thing that under simplex method that one has to remember is that the procedure of computation is so complex, is so difficult that without computer it is hardly possible to cope up with the amount of calculation which is involved in solving business problem. So in the simplex method, the equations are formed on the basis of objective functions and constraints. Since there may be many constraints, if more variable exists in decision situation, there will be numerous equations. So these equations are manipulated in different combinations to find out the optimum combination. All this can be very easily done with the help of a computer. Now speaking about the uses of linear programming. Now simple allocations decisions can be made by observation and experience. But when there is large operation, the problems are always complex, involving thousands of possible choices. Now this linear programming is a sophisticated shortcut technique that makes it possible to achieve solution in few hours that would otherwise might require too much of time to reach that particular point. Now computers are programmed with standard solutions to many of the linear programming problems. So cutting most of the computational time. Not only that, linear programming also makes possible the modification of problems to take into account changes in any element of the problem. Now, once the basic model is set up, a change in a large variable such as cost of labor can be substituted in the equations without redoing the entire analysis. It normally provides information on the most desirable mix of resources as well as problems of product mix and the movement of materials from origin to destination. Now, LP model can be used in variety of decisions related to any of the sector, agriculture, industry, construction, or contract hours, any field. Up until the point where you can mathematically convert the problems and the constraints, linear programming is a very effective way which can be used. So this is all regarding linear programming. So in our today's class, we saw what is operation research, what is probability theory, and what is linear programming, and especially what is decision tree. Then we have gaming theory, queuing theory, and management information system. So management information system probably we shall be doing in our today's class, but since you have a subject of management information system, you study it entirely as a different subject, I would expect you to tell me more about what management information system is for me rather than me telling you. I have a small part in a big chapter, whereas you study the entire subject. So it would be better if you all tell me what management information system is, so that even I can improve my knowledge. So if you want, take a screenshot of this management information system. Try telling it in your own words in tomorrow's class. So what is MIS? How it is when it comes to personnel, equipment and computer. Then it is all about the strategic planning, management control information, operational information, how it is in terms of long-term planning, short-term and daily needs, how it is in terms of top level, middle level and operating level management, the usefulness of MIS, how the designing of management information system is, and guidelines for effective design and some problems. So you should be able to explain this in tomorrow's class. Okay. Now before going to tomorrow's class, we shall finish off today's. We have still two more, that is queuing theory, sorry, and game theory. So what is this game theory? The name definitely sounds interesting, but what is it all about? Now remember one thing, this game theory, it is quite helpful in decision making, especially under competitive situation. Now fundamentally, this game theory attempts to provide an answer to the question. The question is, what may be considered a rational course of action for an individual who is facing with the situation whose outcome depends not only on his own action but also on the action of others who in turn are faced with a similar problem of choosing a rational course of action. Oh, well, that was too much, isn't it? Now, gaming theory just take into consideration as a game of chess. Now, each of the player are competitive in nature, definitely. Each of the competitor has the similar set of situations, yes. But then, speaking of the outcome, now here the outcome of each action not only depends upon the action of the one who is deciding, but also on the action of the other who has been given with similar set of situation. Now in fact this game theory is very simple. The logic of rational decision. Now the game theory was developed basically for use in wars so that actions of the army can be decided in the light of the actions taken by opposite army. Now it was uh, John von Neumann and Oscar Morgenstern. These two people who developed game theory in the year 1944. Okay, they developed with their first edition of Theory and Practice of Game and Economic Behavior. Game theory is especially that body of knowledge or that particular subject which deals with decision making when two or more intelligent and rational competitors are involved under the condition of conflict and also competition. Now, to give an example, maybe managers of two rival companies competing for the major share of the market, union and leaders and management who are involved in collective bargaining, or cricket players involved in winning the trophy, the competitors involved in the game, any game possibly could be which is placed on two teams. Okay. Now, here this particular term game, it represents a conflict between two or more parties. Therefore, this game theory is basically a science of conflict, and a game is described by its set of rules, and these rules specify clearly what each person called player, that is the competitors involved in the game are called players. And it goes without telling that the main object of each player is to choose those particular strategy which would hamper the opponent's game and eventually win a game for themselves. So in a limited overs of cricket, the bowler always try to outsmart the rival batsman and win the game. And this is of course based on the premise that each player in the game is perfectly rational, logical and aims at winning the theory. Now speaking about this game theory model, which is applicable to decision making, now there are something that we'll have to remember. It depends on firstly number of players, secondly the total sum of gains and losses, and thirdly the number of strategies. Now if the number of players is 2, then the game is called as two-person game. Similarly, if the number of person in the game is n, that is any number, 3, 4, 5, anything, it is called as n person game. When the game theory is classified on the basis of sum of gains and losses, Definitely, there are two possibilities. First one, if the sum of gains and losses is 0, the game is called as zero sum game, and if the sum does not equal to 0, then it shall be labeled as non-zero sum game. That is to tell, in a chess game, when two players are engaged in two-person zero-sum game, similarly, where the marketing executive of two firms are competing for the share of the market for the product, they are involved in two-person zero-sum game. Now, if we take the same example when several companies are engaged in an intensive advertising campaign to capture a major share in the market, this shall be labeled as n-person zero-sum game. But then, in this game theory, there are some of the assumptions that are to be made. And whenever we hear assumption, we should always remember that a model can only be true because of the assumption that are being taken. Had not had not these assumption been taken, then there are chances that this particular model may not be worth of what importance it has right now. So the first assumption is that every player who is involved in the game, they are both logical in thinking and rational in acting. That is the first assumption that the game theory makes. And the second thing is that, or the second assumption is that, regarding the objective of each player who is involved in this game or competition, or the competitor's main objective will always be to maximize his profit and to minimize his losses. Now, the assumption regarding the strategy selection is that the player shall always choose those strategy which is suitable for him or her, and the game is always repetitive in nature. The next assumption is that no matter how many strategies are there, all the strategies are finite in number. That is, the strategies that could be selected can be listed. Is there is a end to the number of strategies. And the next assumption is that in no way there can be communication between two players, but then the players shall be fully aware of information which are relevant to the competitive situation. And the last assumption is that the outcome of the entire course of action are known to the players in advance. So these are some of the assumptions which game theory takes into consideration. Now, if we see this particular game theory, it is used most of the times in defense, where these military planners, they used to apply the theory in planning and decision making. Now, what could be the possible advantages of this game theory? The first one is that the game theory is able to develop such a framework for analyzing decision making in competitive situations which are interesting in nature. Now, such frameworks shall not be available through any other analytical techniques. And the second thing is that it is it has this capacity of describing and explaining various phenomena in some of the conflicting situation, such as maybe collective bargaining and also maybe the formation of coalitions. And also the fact that it is highly sophisticated and systematic. The quantitative method enables competitors to select rational strategies for the attainment of goals. One thing that has to be mentioned is that though the game theory is quite useful in defense organization, it is not frequently used in solving the business problem due to the rapidly changing variables and also because of the difficulty in assessing the competitor's response very accurately. That is, we spoke regarding the game of chess. So now, as soon as the opponent makes his move, you will know what his intentions are, or you know what your competitors want it to be. But then it so does not happen when it comes for business situation. Now there are several types of games, depending on the competitive situation. However, the basic objective of all this game is to provide a basis for decision in the light of actions which can be taken by the competitors. So game theory can be used in competitive situations like maybe elections, advertising, and marketing strategies, but especially in military battles. So that is regarding game theory. Now another interesting name, that is queuing theory. What probably could this be? QUEUE, that is QUQ, and the name of the theory is queuing theory. Now, this queuing theory is sometimes also called as waiting line theory. Both are one and the same. Now, it goes without telling, even this is a mathematical study because we are definitely speaking of quantitative techniques. Now, queuing theory, it involves the mathematical study of queues or waiting lines. Now, that is to tell a group of items waiting to receive service, including those receiving the service, is known as queues. Now, the formation of waiting line is a common phenomenon. It might happen at the service station, booking window, retail store. At some point of the time, there may be a long queue, while at the other time, there might not be a single person waiting to get service. Now, in waiting line situation, problem arises either because of too much demand on facilities, in which case we may say that there is an excess of waiting time, or that there are not enough service facilities, or too little demand, in which case there is either too much idle facility time or too many facilities. One would like to obtain balance between the cost associated with the waiting time and idle time. So, the queuing theory helps in achieving this particular balance. Now, it is one of the most common phenomenon of our, particularly our modern day life. Now, we daily see that the customers requiring service assemble and wait in queues to get their turn of service. Maybe we might see this situation in bank, where they have to either deposit the money or withdraw of the money or any other service, or maybe in the railway station to book a ticket, maybe in milk booths, or maybe in the billing center of super buses, which all of us might have at one point of time or other might have been observing, or hospitals, restaurants, grocery stores, cinemas, airports, even when booking tickets in theaters or even in barber shops are some of the examples in which we can identify the application of queuing theory. That is, the nature of customer we can know, the type of service they need will know, the service facilities available will can know. Now, actually, this queuing problem comes into existence whenever the demand for the customer services cannot be perfectly matched by a set of well defined service facilities. That is, in other words, queue is inevitable when demand for limited service exceeds the service facilities. Since a perfect match cannot be achieved, either the customers will have to wait for the service or the service facilities will have to wait for the customer. But then it should be remembered that when service facilities will have to wait for customer, then there comes the result in idle time. When the customers are forced to wait for a long time due to shortage of service, this might result in frustrating the customer, and the organization might lose the customer in the process. So there are some of the specific costs which are associated with first one, the waiting of the customer, and the second one, as we observed, the idle service. Now it is interesting to take into consideration that these two categories of course always moves in opposite direction. For instance, to reduce the cost of customers waiting, service facilities will have to be increased. This results in increasing in the cost of idle service facilities. Conversely, by decreasing the number of service facilities, the cost of customer waiting gets increased, but it decreases the cost of idle facilities. So, the main aim of all this queuing system is to help management in designing one such system which minimizes the sum of cost of customer waiting and the cost of ideal facilities. Now, queuing theory is especially important because unreasonably long waiting line may result in the loss of customer. That is, if a customer is forced to stand in a queue for 1 hour to withdraw the money from the bank, he may feel frustrated and eventually may think of closing the account with the bank. There are always chances. And what has been presented in your PPT is the basic framework of a queuing system. How it works pictorically has been represented. That is, you have input source, that is calling population, customers. Some customers get discouraged by observing the length of waiting line and decide not to join the line. Okay, and then you have queue, that is some customer after waiting for some times in the queue become impatient and drop out of the queue. And queue discipline is maintained, service facility and serviced customers you have. Now, even this queuing theory has some of the assumption that has been made. That is, the size of this population under a queue is finite or infinite. It means that input source is unlimited. That is, customer arriving at the counter to purchase the railway platform ticket is infinite. That is the first assumption. And there are chances that the size of calling population is finite, finite also. That is, when already significant number of customers have entered the queue, closing hours of booking in a movie theater is an example of this particular situation. The third assumption is that there is no balking. What does that mean? It means that all the customers shall compulsorily join the queue. There is no any kind of confusion with regard to that. And the fourth assumption is that there is no renention, that you can see that particular word in the PPT. That is where what happens when somebody leaves the queue is called as renention, and this particular does not happens is one of the assumption. That is, all the customers stay in the line until served. That is to say, customers exhibit patience till they get the desired service. And one more assumption is the length of queue is finite or infinite depending upon the space that is available. And the one assumption which is not at all true is that the queue is disciplined, and the philosophy is that first come, first serve. Now there is very much ambiguity with this particular sentence. The next one is rate of service is greater than the rate of arrival of the customer. Okay. Now what we have to remember is the queuing model, though interestingly are frightening, because the development and analysis of even the simplest queuing model requires highly advanced mathematical and statistical knowledge. But successfully develop the queuing model, it always helps management satisfy the customer by providing better service. Now, if you just try to imagine the actual situation, this is what happens when we book things over the net. Maybe you book certain order with any of the service. Maybe you are, Geomart, you are, Nike, or even the pizza order. The same thing happens. The first come, the first served, and all would be rational there. So you develop it, it would be more helpful. Now the balance between the cost associated with the waiting time and idle time is necessary, because non-provision of enough facilities would cause the waiting line to become excessively long at times. Maybe situation has such, what is happening right now. Now because excessive waiting is costly, because it always result in loss of customers. So this is regarding the queuing sale. And until this part, what we have under your quantitative approach for decision making. After this, we have environmental approach, um, case study approach, and other such approaches, which we shall see in our next class. For tomorrow's class, you have one more separate topic, that is management information system, which I expect you to just go through what it is. Since you have been listening to the class for a long time, it's your work. You understand what MIS is, or management information system. Okay.